Hello, I'm Andrew Purvis. I'm General Manager for Europe, the Middle East and Africa with the Global CCS Institute, and I would like to welcome you to our webinar here this morning. I'd like to give a big welcome to our international audience. We have attendees joining us today from around the globe. Today's webinar is going to focus on the BASTOR2 project, unlocking the potential for CCS in the Baltic Sea. This project, which was partly supported by the Institute, was established really with the primary objective of investigating geological storage in the Baltic Sea region, the potential and the conditions for geological storage. However, once the project was launched, the interest really was such that the scope of the project was increased and now eventually covered environmental impact, communications, acceptance, legal aspects, and also transport infrastructure. The resulting reports, which are currently being published by the Institute, I think they paint a picture of a region that is well poised to take advantages of the opportunities that CCS can offer. In this webinar, we will look at the project, its results, and we'll introduce a BASREC CCS network, a new exciting initiative to promote CCS in the Baltic Sea region. Let me kick off by introducing you to our presenters who will be speaking this morning. The first of those is Per-Arne Nielsen. Per-Arne is an experienced and international industry line manager and management consultant who brings 35 years of experience. Over the last 10 years, he's become increasingly involved in research, development, and deployment of carbon capture and storage. He was the project manager for the BASTOR2 project, which is focused on the Baltic storage of CO2. He's currently working with the Swedish process industry with a view to reducing their CO2 emissions and also coordinating the establishment of a Baltic Sea Regional CCS expertise network. Our second presenter will be Olli Niemi. Olli is a professor at the Department of Earth Sciences at Uppsala University in Sweden, where she heads the Geohydrology Research Group. She's worked in research institutions around the world in Finland, Sweden, Zurich, and at Lawrence Berkeley National Labs in the USA. She has 30 years experience of characterization of flow and transport in geological media. She also has a wide experience within CCS research. She completed heading the large-scale integrated EU-funded project Mustang, which focused on geological storage in saline aquifers. She is also a work package manager in a number of ongoing EU-funded CCS R&D projects, including Trust, Panacea, and CO2 Quest. In the Baltic projects, BASTOR, and also the SwedeStor CO2 project, Olli and her research group worked on geohydrological and dynamic modeling aspects of storage. As we go through the webinar, all attendees are welcome and encouraged to submit questions throughout the presentation, and you can do this using the Questions tab on the GoToWebinar control panel, which will be visible on your screen. The questions will be moderated and posed at the end of the presentation. But please bear in mind you can ask your questions at any time they occur to you. We may not be able to get through all of the questions that we get here today. However, we will do our very best to get through as many questions as we can as we go through the session. So now, without further ado, let me hand over to Per-Arne, who is our first presenter.
Thank you very much, Andy. Yes, this presentation will be about the Baltic storage of CO2 project, BASTOR, that was run over a period of 2 years and was actually concluded in October last year. So I'm very happy to be able to present this to an international audience and also to see if I get this screen right. All right, the project was about building enough knowledge and the main driving forces behind the project was essentially the Swedish process industry that needs to know its options. because towards the middle of the century, the Swedish vision is for the country to reach zero emissions, zero net emissions, and that can only be done if the process industry is included in the portfolio of measures that are taken to reach those reductions of greenhouse gas emissions. As Andy also stated, the Global CCS Institute was one of the funding partners together with the Swedish Energy Agency. We also had a very fruitful collaboration with the Finnish program, CCSP, Carbon Capture and Storage Program, and the project was run under the management of the Swedish energy research arm, Elforsk. The project was organized in 5 work packages, and I will essentially only cover an overall view of what we learned in the project. The work packages, as Andy mentioned, are the geological storage, investigation of the opportunities, the important aspects of environmental impact in the Baltic Sea, communication and acceptance very much related to this, and the fact that the region is a crisscross of international borders. The situation with the international legislation is important. So that was a separate work package. And then with the long distances involved in the region and in our country, infrastructure is a very important aspect also. So that was a separate work package. The project ran over approximately 2 years, from 2012 to 2014. This slide shows the point sources of CO2 emissions in the Nordic region. It was produced by the Nordic program Nordics, and essentially take a look at the locations of the point sources, both in Sweden and in Finland, around the coastline towards the Baltic Sea. You will also see that the largest sources are the steel industries in Finland and in Sweden, and that there are a number of emission sources also in the cement and lime industry and in oil refineries. And the green circles that you see, they are the sources of biogenic carbon dioxide from biomass treatment, first and foremost in the pulp and paper industry. While at this slide, I'd like also to point out the Swedish island of Gotland, which is located in the middle of the southeastern part of the Baltic Sea region. And that is where we focused the modeling for the geological survey. So just keep that in mind as we go forward. Very early on, a question should and must be asked regarding CO2 activities, transport and storage, physical activities in the Baltic Sea region. And that is really, is it advisable considering any possible environmental impacts in this environmentally sensitive area? And it should be stated that there is already rich generic knowledge of the environmental state of the Baltic Sea. So that is a kind of backdrop to any assessment of the risks. The work package in the project took as study material 2 environmental impact assessments made by, one was the Nord Stream natural gas pipeline from Russia to Germany that runs through the southeast Baltic Sea. And the other environmental impact assessment was made by the Swedish oil company OPAB, oil exploration company, that was proposing to drill an exploration drilling looking for petroleum sources outside the island of Gotland. That was then never materialized. However, those 2 surveys, environmental impact assessments, created a very solid knowledge base, industrial knowledge base, for what factors must be controlled when you go into an exploration and deployment phase of any physical project in the region. And they were taken as very good benchmarks for what would hypothetically be the case if you want to go out and start drilling and exploring for a CO2 storage location. So the project, in essence, delivered a detailed checklist and a good work plan for an environmental impact assessment for a test drilling and test injection project, which can be used for the day that the desktop characterization has moved into a phase where physical activities will be its phase. It's also very clear that a serious environmental approach or approach to the environmental risk is one of a few avenues to building sufficient acceptance in different stakeholder groups for storage of CO2 under the Baltic Sea. The project report is very clear that this is a key factor for success. So, in addition to the environmental impact assessment, what did we learn in the project? And this slide summarizes some 400 pages of reports from the project, so it doesn't really make all that justice to all the work that was done. But first of all, there are opportunities for CO2 storage, which Olli will talk about much more in detail and, of course, with much more knowledge than I do here. There are opportunities at, let's call it, industrial scale for injection from the Swedish sector already of the Baltic Sea. There are opportunities for larger, probably larger regional scale CO2 storage, potentially further east of the Swedish border towards both Latvia and probably also towards Kaliningrad, Russia. But there is, at the time of this project, there was less geological data available for making that modeling in detail. So there is more work, much more work to be done before it can be stated with any higher degree of certainty. However, the BASTOR2 project probably is one of the few that has been having access to geological data from 4 countries in the region, making the modeling available at a certain level of certainty anyway. If you want to go further with CO2 storage, it can only be done if the regional collaboration is expanded. That is an absolute prerequisite for developing this further. Transport and storage in the region will, by definition, go cross borders, transboundary. But it was also concluded that the international legislation is not forthcoming enough yet to support this development. There are obstacles built into especially the European Union legislation and directives. However, these are clearly defined through the report of this project, but not necessarily seen as showstoppers given the time perspective that we operate with here, although the process of changing the directives could be a slow one. Transport systems are of the scale, investment and physical scale that really makes them defined as infrastructure and as such a national interest rather than only single project interest. In this case, not only national interest but also international, which prompts not only single government initiatives but also joint government initiatives and actions. Of course, linked to the corresponding tariff systems, etc. The final bullet point here points to the fact that in addition to the environmental impact, the general perception of climate threat and global warming will be relating very much to the opportunities to build public support in the public opinion and in other stakeholder groups, not least with the policymakers, politicians. So that is, of course, the development of the global warming debate goes hand in hand with the potential support for CCS in the region. Another thing that is very clear is that 2050, if that is a kind of target date, it's only 1 or 2 investment cycles away. 35 years, that is the period that we have to come up to large-scale activity here. Which is very short time for the process industry to make modifications to the process in order to capture CO2. So we don't have all that time. Early action is actually of essence, even if we sometimes tend not to talk about that. The project then put up a kind of vision to stretch for, which could be a demonstration project based on either the SSAB steel furnace in Oxelösund or the Heidelberg Cementa cement plant in Slite at Gotland. An idea could be, a vision could be to capture CO2 in either or both of those plants for storage in the Dolders closed Dolder structure from the Swedish territory here, and setting this up with ship transport, at least initially, could be a fast way to reach deployment. And staying in the Swedish sector would actually also allow the project to operate under the current legislation, essentially. Or of course, the permitting process would still be a lengthy one. This vision to stretch for would mean looking for a demonstration project being in operation maybe by 2025 in order to support the long-term deployment. Post-BASTOR legacy, that sounds a bit large here, but essentially right now in Sweden, some 20 plus partners from industry, academy and agencies are working to develop a strategic Swedish research and innovation agenda, the result of which will be put forward in the public domain in the summer of 2015. Another development that is parallel is the Baltic Sea Region Energy Cooperation, BASREC, and the Nordic Council of Ministers supporting a regional CCS expertise network, which is actually being established at this point in time, and it should be there in support of supporting the long-term development in the region towards deployment of CCS. And as you can see, this goes very much hand in hand with the recommendations of the BASTOR geology work package that we will hear about in a minute. This slide is an invitation to anyone attending this webinar. The second actually regional CCS conference will be held in Tallinn next week, 22nd, 23rd of April, Tallinn, Estonia. And registration could still be organized even if we're late right now. And one way of doing that is to write down my contact details and contact me after this webinar, and we will see to that is happening. I think that is all I wanted to say right now, so I hand back the controls and will be available for questions later on.
Yes, so I will talk about the modeling work of the geological part of storage in this as part of this BASTOR project. I want to acknowledge my co-workers at Uppsala. There's a list of names who did the dynamic modeling work, and then also SLR Consulting in Ireland, who was doing the data analysis, doing the big work of collecting data and constructing the geological models. And Richard Vernon and Nick O'Neill gave a presentation earlier on this same forum about the more focused on the geology part. So I will now talk a little bit more about the dynamic modeling we did. So I will briefly say something about the preliminary storage capacity estimates, and then move on to the static modeling of the geology in the region, and then some examples of the dynamic modeling of CO2 injection, and then some conclusions and recommendations that we came up with. This gives you an idea of the area that we are looking at. Here is Sweden, here are the Baltic countries, and this is the Baltic Basin. And before starting the BASTOR project, we were aware of these layers, reservoir layers that exist there, that there are sequences of Cambrian sandstones sealed by good Ordovian carbonates and seals. So this was kind of the starting point. What was done in BASTOR, extensive data was collected. This map shows again the surrounding countries. You see that there are many countries that are involved. The blue lines are the borders. And SLR collected data from 4 different countries, from Latvia, Russia and Poland. Some data was purchased, and then some of the partners, Swedish partners, supplied data. And there were altogether 50 wells and maps and well logs that were used in constructing the geological model and geological understanding of the region. There was a ranking of the sub-basins. This is again the map, and Sweden and the Baltic countries here. And now I'm having a little bit. Do you see my entire screen? I guess. So there was a ranking of the basins, and especially this basin of here. This Slapsk border zone was considered attractive. Some of the other basins got a good ranking also, but this was attractive, highest rank, and also it was close to Swedish territory and Swedish sources, so it was interesting to us for that reason. There was also, once this ranking of these basins was done, SLR did preliminary capacity estimation of the formations, and the total capacity of the Cambrian rocks below 900 meters, which is the limit for supercritical CO2, was over 16,000 million tons. And significant formation was this Dalders monocline that is second on the list. And this was on this border formation that I showed in the previous map. So this formation, then this Dalders monocline, was one of the areas that we took up in more detail in our modeling. And this slide shows the porosity maps and permeability maps of this monocline. And again, you say Sweden and the Baltic states to get an idea of the scale. And the porosity and permeability are lower in the western part, and this part is also deeper down. Here we have higher permeabilities and porosities in the east. This data, this permeability porosity, comes from this well data that I mentioned earlier. Caprock Integrity was also looked at by SLR. This slide is just to point that out, looking at what kind of failures in the caprock can take place, and then choosing the region for our first modeling study where we have highest confidence, perhaps, or most knowledge about the caprock properties at the moment. So the model region for the dynamic modeling, where we wanted to then really look in more detail what would happen if we inject CO2, was this western part of the Dalders monocline, this ABC region here. And you see some of the porosity permeability values from 10 to 300 millidarcies, so the lower end of values is not very high. And these are the depths, but this is for the entire Dalders monocline. Now we analyzed it, modeling this part, and we chose some injection wells there and looked in detail how much could be injected. We chose, we wanted to be very confident with our modeling. We chose different modeling approaches and also different modelers. And we're thinking that if we use different approaches, we can be very confident in our predictions. We used analytical and semi-analytical models to look at the pressure evolution, to get a preliminary estimation of how much could be injected. And then we used numerical models, both this kind of really full physics stuff to massively parallel version and a more simplified vertical equilibrium models to look in more detail about the injection events. And then finally, we also looked at the plume advancement after the end of injection with analytical and tough simulations. This plot shows the first estimates of the pressure calculation with the analytical model. We have the injection rate and pressure, and we cannot increase a certain pressure, which in our study we had to estimate from just from literature. We didn't have the fracturing pressure information for this site, but we assumed based on general knowledge a certain pressure that should not be exceeded. And you can see here that the thickness influences the you see the red surroundings here, red circle here, and this is the threshold that should not be increased. And you see that as injection rate is increased, pressure increases, and the thicker your formation, you remember this, our thickness in this Dalders monocline varies. So 0.6 million tons per year we could inject from one well without exceeding the pressure. Then if we move on and look at how we can change the amount by increasing the number of wells. Here is again the total injection rate and number of wells. For example, with 7 wells, we can go to 3 million, a little bit over 3 million tons per year. And then permeability is a very big, has a big impact. And you can see that with 80 millidarcy, which is not that big number, we get somewhere close to 1 million ton. 1 million ton per year, or 0.9. So this gave us some idea. We said that our base case is that we can, from 5 wells, we could inject 2.5 million tons per year. This could be compared to, for example, Sleipner, where you inject 1 million tons per year. Sorry, I'm having a little bit problems with my screen. Okay, so this analytical model gave some preliminary understanding, and then we went into the numerical model of different various complexity and chose some injection wells where to inject. And this plot shows on the left-hand side the pressure increase, and this shows the plume at the end of 50 years of injection. So this is quite a big time of injection. Maybe 25 years is a more realistic. And now in this case, it's 1 million tons per year. The message from this is that the plume is quite small, even after 50 years and even after 500 years. While in this case, with these permeability values, we had the the pressure increase becomes the limiting factor rather than the migration. The numerical results agreed quite very well with the analytical ones, given that here we could have more heterogeneity and variability in the properties. This plot shows even more full-scale modeling with TAF2 massively parallel. It essentially just shows similar results, pressure increases than the simpler model on this slide. But we can also see from this slide that this well location was very badly chosen, intentionally badly chosen, seeing that when you have the fault zones, tight fault zones near, you get pressure increases. This is not big news, but we wanted to test that also. Then finally, we also looked at the end of the injection, what would the plume migration be? We see here that the plumes are not very big even after 50 years, but what happens then? And we again used TAF2 simulations and analytical simulations, and this plot shows that after 3,000 years, the plume tip would have spread 6 kilometers. So this is not very, it will be retarded and dissolved, etc. Before reaching, for example, Sweden. Or so this doesn't seem to be for these parameter values that we were looking. We were doing a lot of sensitivity studies also, not a problem. So the pressure increase is actually seems to be the limiting factor in this domain that we were looking at. So then if we go to some conclusions, we can conclude that there seems to be a large theoretical storage capacity in the Baltic Sea under the 900-meter limit. We realized that the injection rate is very sensitive to parameters such as the formation thickness and permeability. And the present modeling does not address all the variability. This was a preliminary model. In this southern Swedish sector that the dynamic modeling was done that I showed to you, it seems that it could be suitable for storage for local, not the entire Baltic Sea region, but for more local industrial use. There are sweet spots elsewhere, and it is of it's very interesting to go and look at other regions also than what was possible to look in this preliminary study. The recommendation, we recommend additional modeling and different injection scenarios, horizontal wells, more detailed analysis of the data, even for this site that we were looking at, and then expanding the modeling to other regions in the Baltic Sea. We also give some recommendations of combining the seismic data to the well data. We would need better information about the fracturing pressure. Now we were assuming the pressure limits. And it would be interesting to get more data, especially on the northern part of this Dolders monocline. Now we were looking at the southwestern part. And then maybe most important is that we need collaboration with the countries and partners around the Baltic Sea to get good work done. So thank you for your attention, and here is my email address, and there is also the report where this work is presented. We are also almost ready with publishing a journal article about this work. Thank you.
Thank you, Olli, for your presentation. I would like to invite the audience to submit their questions. We have received a few as we've gone through the presentation, which I will ask our panel shortly. If you have any further questions, please feel free to enter them now in English, preferably into the GoToWebinar control panel, which should be visible on your screen. The first question we had was regarding the reports, and maybe I'll cover that one myself before giving that to talking to the panel. We were asked whether the reports that have been produced by the BASTOR project are publicly available? The answer to that is yes. As things are, 4 of the reports are available via the Institute website. If you go to the Institute's website, www.globalccsinstitute.com, click on the publications link, and if you search using the term BASTOR, that will produce links to the first 4 reports that have been made available. So in terms of questions from the audience, Piranha, what's the total volume of emissions that could potentially be collected from the Baltic region? And what would the volume be for the Swedish pipeline network that was visible on one of your slides?
I'd like to answer that question a bit less exact than stating the number that can be captured. But if you look at Swedish industry, the Swedish process industry point sources of CO2 emissions in total, the volume is around 12 to 15 million tons. It's depending of course of the economic activity and the export industry, etc. So that is a bit fluctuating, but that is the Swedish total gross emissions that we have been using for the modeling of the infrastructure system on the Swedish side. In total, how much can actually feasibly economically be captured and stored in a long-term scenario, I don't dare to estimate that today without really knowing what kind of price of carbon emissions we're looking at, for example, or what kind of control mechanisms that will be in place. If you look at the Baltic Sea region, I think we have earlier been talking about a total potential maybe of 50 million tons, 50 or 60 million tons of CO2, including sources within up to 300 kilometers from the coastline. And that would then include also power plants east and southeast of the region of the Baltic Sea. But there I don't have all the details. But we talk about substantial numbers of carbon dioxide emissions that need to be handled over time.
Okay, thank you. Olli, in terms of test injection, are there any plans for test injections in the region that was covered by the study? And if that's the case, when might that happen?
There is no planned time, but in BASTOR we made some kind of a plan for how the test injection could go, and there is another parallel project that has been focusing only on Swedish territory and looking at the more of scientific type of injection, where there is also a plan to go to a characterization phase first and look at 2 places in Sweden that are crossing these formations in the Baltic Sea. We don't know about the fate of those yet and how this could proceed. But in general, if this kind of test injection would go, it takes a year or 2 to characterize the site first, and then we are talking about the lead time of some maybe 5 years to have a test injection completed, a scientific test injection.
Thank you. What's the role of national governments in enabling CCS deployments within the Baltic Sea region? Do you need government's explicit support to support the private sector, involve the private sector's investments in CCS? And really, what could the Swedish government do to support the country's CCS development?
I'd like to answer that one, stating first that any development in this sector the large point sources and developing carbon capture and storage must go hand in hand with any overall program in the abatement of CO2 emissions to the atmosphere. And as such, I think that from a Swedish point of view, there is now a recognition that in order to attain any ambitious greenhouse gas emission reductions targets for 2050, the process industry needs to be included, because the percentage of total is of the total emissions is around 22%, depending on the fluctuations, and therefore the political debate has not been very strong so far. The Swedish government is currently trying to focus on which are the measures that need to be put in place to reach this target by mid-century. And CCS deployment cannot be done without the government taking an active role, supporting, I would say, first of all, a holistic or a system perspective on research and development, which goes all from capture technologies adapted to the process industry's needs, all the way via infrastructure development and, of course, support for the characterization of storage locations, as Olli talked about. So that is one area where the government must be involved and support very focused research towards this development. And the other thing that needs to be done is for the country to develop a strategy for the deployment of CCS, or at least for analyzing the effects of deployment of CCS, and what would be the measures that need to be taken to get this into place, and in an interplay between industry and government. And the third area that I would consider was one of the results of this project, to really investigate and suggest a demonstration project from one of the industrial sites, because this would really help focusing all efforts on research and technical development, and also the political measures, permitting processes, environmental discussions, etc., focusing on one central project that would really build the information and the knowledge base that is necessary for large-scale deployment. So those three areas, I think I would point to: CCS strategy, demonstration project, and a system perspective on research and development.
One of our speakers today mentioned a potential annual capture rate of around 50 million tons in the Baltic Sea region. Perhaps it's a question for Olli. Do you see injection rate in the reservoirs as being a limiting factor in terms of what can be stored?
Now, the part of the Dalders monocline that we were studying, that would not accommodate such amounts, of course. But there are regions that have higher permeabilities and more areas. So this is one of the conclusions, that we should look at those also in more detail, and need more data for that, and more modeling. We can also look more at the part that we were already looking at, but that would be too small injection rates for the entire region.
Okay.
But at large, I don't think there is reason to think that there wouldn't be possibility yet, based on the information we have so far.
What would be the distance, or the typical distance, from the industrial facilities to the model storage site, and what implications could you draw from that to the cost of storage in the region?
I guess this is more for Piranha.
Thank you, Olli. That's kind of you.
No.
Could you repeat the question, Andy? I was unsure what the question was about, really. The cost of storage? Or the cost
It was
of
really about the distance. So what's the distance from the industrial facilities or the industrial clusters to the storage site that's been modeled, and really the implications of that distance to the cost of storage within the Baltic Sea region?
You can say that if you compare the cost of transport for this region and what we have been looking at in this project with cost of transport that has been estimated for large CO2 volumes from the central parts of Western Europe to the North Sea, with the large volumes and also the shorter distances, you can say that transport costs in this area would be probably become higher because the volumes per site are lower and the distances are greater between the point sources and a potential storage location in the east part of the Baltic Sea or under the east part of the Baltic Sea. It is, I think it would be wrong to go into examples or details here, but for the demonstration project, I think I'm not quite certain, but that can be checked, and I can check that after the webinar directly. I think we talked about a distance of 300 kilometers or roughly, and if you go all the way to the north to the Bay of Bothnia, where you have the two main steel plants of SSAB and Runic, the Finnish side, then the distance is of course much greater, and you would see that the cost of transport would be higher. And while on that topic, I would also say that only for the site that was showed in my slide about demonstration project, that is the only real hub on the coastline where potentially pipeline transport has been estimated to be competitive cost-wise with shipping. For essentially all other sites along the coastline, the cost estimation has come out favorable in favor of shipping.
Okay,
I don't know if that answers the question, but I wanted to be a bit more elaborate on that.
That's good. Thank you.
We have not been calculating or estimating cost of storage per se. So the only cost estimations have been focusing on transport.
You talked about shipping as being the initial method proposed, both in the presentation and in your previous answer. Do you have a feeling as to how much of a cluster network in terms of volume would be needed to be established before pipeline transport would start to become viable?
As I said, most of the clusters, we actually modeled, I think 5 or 6 clusters, and this was done very well by the Chalmers University of Technology in Gothenburg. We modeled those clusters, and actually for all of them, but the cluster that was shown in the slide for Oxelösund and Gotland, shipping came out over long term and also at full volume, platform or plateau volume, as we said. Shipping came out as the lower cost alternative compared to pipelines. And of course, as is the case with shipping, also at lower risk, considering both the need for really project commitment from all potential sites to have the volume included, and at a certain point in time, and of course also the other financial risks that are higher with the higher capital investment that pipelines would require. So the answer is for 5 out of 6 clusters, pipelines could really not be perceived cost competitive. And I repeat that this is pertaining to cost.
Thank you, Piranha. Well, we're coming to the end of the time we have allocated. I have just maybe a final couple of questions I could ask. Look, a number of our participants have asked how could they become involved and how could they collaborate with the ongoing activities around CCS in the Baltic region. Piranha, what advice would you give to anybody who might be viewing or listening to this webinar and is stirred to wish to be part of this initiative going forward?
First of all, I'm almost touched by those questions. That's fantastic, and I would do the following: recommend to go into the current website of the Baltic Sea Region Energy Corporation, where the CCS Expertise Network has a part of that site. The website is www.basrec.net, and go and look for the CCS initiative. There you will find information about the establishment of the current network. If you also want to connect directly with myself, you hopefully got my contact details on my last slide before. And anyone who wants to contribute to this development is of course welcome. So thanks for that question.
Perhaps finally, Olli, how much more can be learned about the capacity or storage capacity before actually going to the field and doing some test investigations?
There is quite a lot we can do still, analyzing more the data, collecting more data from these countries around, and doing deeper analysis. I think but of course then it's important to start thinking about going to the field also and starting testing. But there is, it's a wide region, large region, and many data sources, so we can improve our models quite a bit without going to the field also.
Thank you, Olli. So we are, as I said, we're coming to the end of our time, and there was a lot of interest in the subject. Unfortunately, we weren't able to get through all of our questions we received in the allowed time. However, if you do still have questions, please submit them to the Institute through our webinar inbox, which is webinar@globalccsinstitute.com. If you wanted to get in touch with Piranha or any of the other BASTOR team, I'd encourage you to use that email address, and I will make sure that any emails received will be forwarded to the right people. The webinar today has been recorded, and it will be made available on our website, along with a copy of the presentation in the next coming days. Lastly, as you're leaving this session today, we've put together a very quick 3-question survey. We'd really appreciate you taking the time to complete it. This will help us improve our ongoing webinar program. I'd like again to thank our presenters and our support team. I certainly hope you found this webinar valuable. And once again, thank you all for your attendance, and I wish you goodbye.